Okay, so we're going to work on this problem here again, the one I have highlighted in blue with a green X next to it. We're looking at a street light mounted on top of a 15-foot tall pole. Man 6 foot tall away walks away from the pole at a speed of 7 feet per second along a straight path. How fast is the tip of his shadow changing when it was 40 feet away from the pole? Okay, so I gave an answer to this during class. I wasn't wrong, but I didn't go far enough. So let me start from the beginning and rework this problem to try and make sure that you guys are able to get the correct answer at home. So here's the situation. You got a 15-foot tall pole, 6-foot tall man, and the tip of his shadow is some distance away from the wall. We don't know y, we don't know x, but together x plus y gives you the length of the base here. Now the important thing to see is that this orange triangle here and the larger green triangle are similar triangles. And what that means is that the ratio of their sides, that is the height to the base, and then the heights to the base again, are in the same proportion. So we can set up this proportion. Now, the length of this is y plus x, and that's important to keep in mind. That's going to be the rate at which it's going to be the length, it's going to be the tip of the shadow, the distance from the wall to the tip of the shadow. We want to know how that distance is changing. But first I cross multiply with these two, and I get 6 times y plus x equals 15x. I'm going to solve for x in terms of y. So that is, I'll divide both sides by 9 here and put that in lowest terms. And I get this nice expression here that is x is 2/3 y. Now the problem itself told us that dy dt, that is the distance, the rate of change of the distance of the man from the pole, is 7 feet per second. With that, and with this, I can differentiate this relationship with respect to t, and then substituting in dy dt is 7, I get dx dt is 14/3. Unfortunately, if you put that answer in, that's wrong. It doesn't go far enough. What that is, that's the rate of change of the length of the shadow. We want to know how fast the tip of that shadow is moving. And for that, I need to know the rate of change of y plus x. So let's look back at the problem real quick. It says, how fast is the tip of the shadow moving when he is 40 feet away from the pole? So that's the rate of change of this plus this. So there's 2 ways you can do it. Let's start with this way. If I differentiate with respect to time, x plus y, I'll get dx dt plus dy dt. Now dy dt, we know that's 7. Dx dt was 14/3. If you get a common denominator, then that's how these things are changing. 35/3 feet per second. On the other hand, if you say, well, x is really 2/3 y, 1 plus 2/3, or 1 2/3 can be written as 5/3. If I differentiate that with respect to t, then it's going to be 5/3 times dy by dt. Since dy by dt was given as 7, 7 times 5/3 is 35/3. So either way, 35/3 should be your correct answer. Hope this helps. Thanks.